This is probably going to sound a little insane, but have you ever wondered why the metric system seems to have units for just about everything, except for angles? I mean, think about it. 1,000 grams in a kilogram, 1,000 millimetres in a metre, and 360 degrees in a circle? Well, it turns out there is a metric unit for angles. The gradient. And there's a few good reasons you've probably never heard of it. But to fully understand the obscurity of the gradient, why I spent hundreds of hours building a tool to measure them, and how that, once again, involves basically all your favourite pretensioneers on YouTube, there's a few things you should probably know. About a year ago, my friend Eric from the UK was cooking up a little something. Something burning in here? That little something would later become known as Toolroom Takeover 2025, a major collaborative event that's still best described as a machinist's secret Santa for Christmas in July, in August. I dare say you've figured this out by now, but we decided to give it another go. And this year, the name drawer decided I'd be gifting to Marius Hornberger. Figuring out the perfect gift for Marius was no easy feat. I mean, the guy has an incredibly well-equipped workshop, peppered with all manner of custom over-engineered solutions, like his height-adjustable portable vice stand with deployable casters, and his incredibly tidy, tool-post-mounted combination milling and grinding spindle. But I know for a fact that Marius is still using degrees for all things angled in his shop. And I also know that he's German. A cultural identity renowned for specificity and attention to detail, not to mention world-class utilisation of the metric system of measurement. So I reckon that, like me, he must be unreasonably bothered by this glaring oversight, and nothing would make a better gift than the 400 gradients found within a metric circle. Of course, having set the bar for myself so high with last year's submission, I knew that this tool had to be special, and preferably far more complicated than it has any right to be. Which hopefully at least partially explains how I ended up with this fucking thing. Each of the 35 components required to effect this design was sure to push the limits of my capabilities, and to be honest, I wasn't completely sure I'd be able to pull it off. Every step, from tapping the threads to shaping the glass, to cutting the gears.
See that gap? That's no good at all.
Involved working with materials I've never encountered, techniques I've never practiced, and all at a scale that's really quite difficult to comprehend until you experience it firsthand.
Oh no.
So we better get started.
So, after a pretty ridiculous amount of time in CAD and then CAM, I'm finally ready to start machining this thing. So first I'll just cut it down at the bandsaw, and then we can get it bolted to the milling machine and hit the cycle start button.
If there's one thing I've learned from all the stock I've ever removed, it's that, where possible, it's best to let someone else handle most of the stock removal. And gauge plate is a brilliant way to do it. This particular stick tastes like O1 tool steel and comes pre-ground in all your favourite nominals, meaning we can skip the facing and jump straight into the pocket, responsible for housing the as-yet theoretical mechanics. Now at right about 12 millimetres thick, I could definitely argue that the girth on these arms comes down to functionality and a premium, weighty feel in the hand. And I will argue that. But the truth of the matter is that while I was designing the gears I wanted to fit inside the arm, I just couldn't find the courage to commit to anything thinner than 1.2 millimetres. All cowardice aside, the cavity set to contain said gears was coming along nicely as a steady progression of smaller and smaller end mills reached into sharper corners and tinier holes, until none of the stock left wasn't supposed to be, at least as far as the inner workings were concerned. Those inner workings were next, and things were about to get sticky.
So now that I've got the main casing machined, I can move on to the really tiny stuff that goes inside. I'm going to use super glue fixturing, and I should be able to just run a slotting operation, leave some tabs so that the parts don't go flying. Fingers crossed.
And I know that sounds like wishful thinking, but I had a trick up my sleeve. See, the cyanoacrylate you're thinking of is probably the clear and rigid kind, which is much less than ideal for metallic bonding. But some clever bugger realised that all it took to solve that was a little bit of rubberizer. And so I present to you the miracle of Loctite 480, or at least its generic alternative. So all I had to do was splooge a little superglue on some similarly precision ground but slightly thinner 2mm stock, slap it down to a specially prepared plate, and I was off to the races. Now I know it's a little difficult to see what's going on under all that coolant, but you'll just have to take my word for it that the tiny little 2mm 3 flute was happily taking care of the bores and ramping contours required to realise each part. So while the machine moves on to a final tickle with a chamfering tool, let's take a moment to discuss their purpose. The first step in understanding the mechanisms at play here is to accept the gratuity of the overall system. With that challenge taken care of, a number of others arise to take its place. See, at its core, the task at hand is to take the rotation of one axis, amplify it, and display that amplified output on another offset axis. Simple enough in theory, and not too complex in CAD, but as soon as it's time to bring things into the real world, the tolerance stack-up inherent to all things manufactured in a rented single-car garage means the odds of boring the gear seats both on size and in position, while simultaneously cutting each gear tooth to the correct depth and pitch circle diameter, are quite literally less than zero. At the same time, any amount of backlash in what's supposed to be a precision instrument is all it would take for me to lose what little cognitive stability I still possess. So to circumvent the certainty of erratic angle readings, I planned to float the gears on these spring-loaded arms.
And that plan was devised and later revised using Onshape. Onshape takes the risk out of iterating with its built-in Git-style version history, meaning I'm free to explore all my ideas, safe in the knowledge that reversion is just a few clicks away. Try Onshape Professional, free for up to 6 months, using the link below.
This slight degree of freedom would allow the gears to maintain full mesh, despite the slight yet certain discrepancies in concentricity and tooth form, resulting in precise and repeatable, if not entirely accurate angle readings. At least, that was the hope. For now, there were still a few stray burrs to take care of. Now I know that in the grand scheme of tiny mechanisms, these aren't the smallest of parts. Nevertheless, the aid of a digital microscope was indispensable in the pursuit of an even, hand-finished chamfer on their underside. I say in the pursuit of, because all the microscope really did was highlight my lack of hand-eye coordination at such a small scale. But the positioning of such imperfect facets on unseen faces, combined with the unlikelihood of Marius scrutinising my work under similar magnitudes of optical enhancement, meant that, at least for the time being, it was time to move on.
So all of these parts are looking pretty nice, but I don't want to get too far into finishing them before I've made it a little bit further on the rest of the parts, because otherwise I'll just go down a rabbit hole and I'll never finish the thing. Same method, same stock, fingers crossed it continues to work really well.
And things really had gone well so far. So it should come as no surprise that my first attempt at the 7th part wasn't quite a success.
And I've already scrapped it. See, that hole is actually supposed to be in the middle of that part. I'm going to leave that glued there and I can maybe get another part out of it later. But for now, I'll just cut another one of those and try again.
With a little more attention paid to the probing, my second attempt was much improved.
As you can see, fucked, not so bad.
My good fortunes held true for the remainder of Op 1 and throughout Op 2, which honestly really surprised me. I was half expecting this 1mm end mill to explode at the mere whiff of real tool steel. Instead, the faceplate started to take shape, and now that I had some momentum, along with a finely tuned set of feeds and speeds, the needle and dial swiftly followed suit. Now the sensible thing at this point probably would have been to continue on down the list of components until all 35 parts were ready for finishing. But the carnal desire for makey thingy shiny had me quenching, lapping and hot bluing the delightfully dainty dial spring before I even knew what was happening. Springs aside, you might remember right at the beginning of this video, I mentioned that there's a few good reasons you've probably never heard of the gradient. I mean, if it wasn't for a stray shower thought.
Wait a second. Why are angles sexagesimal?
I'd likely still be oblivious to them myself. Just a quick message for all the geologists, surveyors and 18th century Frenchmen watching. Please keep the comments about how you use gradients every day to yourself. The rest of us live regular lives. So to understand why the gradient never properly stuck, we'll need to take a closer look at its competition. Now, the origins of the degree are ancient and more or less a mystery. But from my limited research, most sources seem to think they probably came out of ancient Mesopotamia, some 3,000 to 5,000 years ago. Full disclosure, I'm not an engineer, or a historian for that matter. But if I had to make a guess as to why they chose 360 divisions, I'd say it's probably something to do with the fact that the radius of a circle happens to be the exact distance between 6 equally spaced points along its circumference, a phenomenon easily observed with a simple pair of dividers. And I know what you're gonna say, but Rowan, after a cursory Google search, the earliest example we have of a pair of dividers only dates back to 49 AD. More than 2,000 to 4,000 years after the apparent inception of the degree. Well, consider this bent stick. Though admittedly limited in its range of radiuses and material marking ability, it's more than capable of demonstrating the relationship between the radius of and hexagon circumscribed by a circle. So I think it's fairly reasonable to credit the folks behind such classics as written language, beer, and the goddamn wheel with such an astute observation. Anyway, the citizens of ancient Mesopotamia, these so-called Sumerians, favoured a base 60 or sexagesimal numerical system, and dividing those 6 equal arcs a further 60 times gives us, bada bing bada boom, 360 degrees. We'll get to gradients shortly, but for now, back to the build.
So I spent most of yesterday mucking about with polishing and finishing. Used this little spring as my first practice. I learnt a few things. It's a lot easier to polish something that's hard. I guess that makes sense. I mean, the whole time I was doing that, I was basically avoiding doing the rest of the cam for the other parts. So I should probably get on with that.
If you've ever cut gears before, you can probably guess that chief among the origins of that avoidance was the incredible amount of preparation required before cutting even the first tooth. In the case of the first and largest gear in the train, I first had to pull a rough blank from that 2mm tool steel. To nail the final dimensions and keep everything concentric, the lathe was obviously my best bet. But to hold the blank for this operation, not to mention the dentistry to come, I'd need some kind of arbor.
So basically this is just an improvised chuck, and I'm going to super glue the gears on the end here so that I can turn the inside and outside diameter at the same time. Hopefully nothing goes flying.
Thankfully, the glue held strong through facing, turning and boring alike, leaving me with the perfect canvas for a 60-toothed module 0.5 gear. Then all I had to do was hoik the 4th axis onto the mill, hook it up, bolt it down, tram it in, add the arbor, dial that in, load the gear cutter, set my Z0, set my Y0, set my X0, and I was finally ready to get the 20 involute flutes chipping. A lot of this setup could have been avoided with the help of a tool post mounted spindle on the lathe. Kinda like the one Marius made a little while ago. Unfortunately, I haven't really got the time to build one for myself. What with all these obscure metric angle unit shenanigans. Which is where the sponsor of today's video, PCBWay, comes in. Because aside from being a leading manufacturer of custom printed circuit boards, PCBWay offers a huge range of advanced CNC machining services, all the way from 3 to 4 to 5 axis milling and turning, to 3D printing, laser cutting, and sheet metal bending. The gear cutting on this project, and some internal grinding jobs in my horoscope, were enough of a push for me to finally sit down and design a quick change spindle holder and motor mount. Then all I had to do was upload my designs and fill out a few options like material selection and surface finish. After that, the only thing left to do is kick back and wait for the box of goodies to arrive.
So if you need custom parts for your side project, check out PCBWay using the link below. The first 100 customers to use the code
PCBWay-not an engineer 10
can get
$10 off orders over $30.
I'm looking forward to employing this tool post grinder on future instrumentation endeavours, alongside this quick change chuck holder and these quadruple barrel boring bar holders. But for now, thanks to PCBWay for sponsoring the video, which we should really be getting back to. When the time came to tackle the second largest gear in the train, all those blank and arbor and zeroing and cutting steps were repeated, and that's when I noticed a problem.
So I got the 2 large gears cut yesterday. This one turned out beautifully, but this one is a little thin in the tooth, has a little bit of slop in it. I feel like it's because the teeth were not fully supported in the cut. I'm gonna try recutting this with a solid backing. Hopefully that solves that issue.
Spoiler alert, that issue was not solved. But upon its completion, inspection of my second attempt showed enough of an improvement in tooth form to lull me into a false sense of security.
It's way better.
So I moved on. The smaller gears had a few more features axially speaking. So I switched over to some silver steel bar stock, which should still be easily hardenable. If you like easily hardenable bars, you should like the video. And if you subscribe, I'll know you want to see more. Now the shafts and shoulders on these parts are pretty small, with some fairly tight tolerances on their various diameters. On top of that, the position of each of the shoulders separating those diameters was fairly critical in achieving proper alignment during the final assembly. Unfortunately, all the carbide inserts in my collection feature some degree of corner radius, which would certainly leave each and every one of those shoulders with a small but quarrelsome fillet. So I turned to good old high-speed steel, grinding a pair of extra sharp tools that would hopefully make those inside corners as crisp as possible. Step 1 was to turn the major diameter. Then I could step down to a 3mm journal, which would eventually be supported by a bronze bearing. I reduced the end of that journal to a 2mm tenon to accept a press-fit retaining collar, then switched to my pseudo parting tool. The backside received a simple shoulder and spigot to add a little axial space between the teeth's mesh and mating components. And then I could complete the parting.
So the next job is to cut some teeth into these tiny little guys. I've learnt my lesson about having some material behind the teeth that you're cutting, so I've made up some little cones. The 3mm shaft on these pinion gears fits into a reamed hole, and I'll just glue those in. And then I should be able to cut the teeth, no dramas. See how we go.
"20 passes later, the larger of the 2 pinions was complete. Tragically, its 15-toothed counterpart didn't turn out quite so well.
See that gap? That's no good at all. So what was supposed to be an afternoon of gear cutting has turned into 3 days of arbor, gear, and mistake making. Anyway, hopefully I can get it right today.
I'd love to be able to walk you through the next 2 days of troubleshooting in its entirety, with all of its red herrings,
I think I could go slightly deeper.
side steps,
And then I just have to remake this one again.
and solemn soliloquies.
Fuck!
But to tell you the truth, I kinda blacked out for most of it, so it's hard to say for sure what exactly led to this not insubstantial pile of scrapped gears. All I really know is that I'm pretty sure the root of my struggle came down to some sneaky axial runout in the too cheap to be true tooling.
Teeth are going like this. So they're cutting wider than they should be.
And the actual solution turned out to be a shallower than ordinarily sensible pass with the involute cutter, followed by a slight relieving of the root with a 0.5mm slitting saw.
I think we've done it. It
It had taken all week, But I finally had a complete set of angle gauge gears that should, in theory, be able to take rotation from the lower arm, double it, then double it again, to display a magnified reading of its position. But I'd still need a few more parts to know for sure. While not strictly necessary to the mechanical function of the tool, a window would be pretty important in the act of actually reading its output. Acrylic would have been the easy way out, but it scratches easily, and any slight deformation would have it looking less like a precision instrument than a carnival mirror. So in pursuit of optical clarity, I opted for glass instead.
So I've somehow got to cut the glass for the window, but I don't really have the tools to do that. Thankfully, I know someone who might, so let's go on a little trip.
That someone was Alex.
Got it very nice. You just came here to make me feel bad. No, but I make you.
And the somehow was his almost brand new and very barely abused water jet cutter. After a little troubleshooting, we finally managed to cut a usable pane that fit perfectly to the housing, along with a few spares, just in case.
Well, that went extremely well. Back to the rest of it.
The spigot forming the main connection between the two arms of the device had a few roles. Primarily, the tolerances and material properties of this part would heavily inform the overall feel of the pivot and therefore the entire tool. So I decided to make use of some bronze for its high machinability and low wear properties.
Okay, what the fuck is that?
Fresh out of 22.3mm collets,
Damn.
I clamped the bar in a 3-jaw and got to work on turning its largest and least critical diameter. Next, I necked down its end to something like 16mm for a nice fit to that bore in the lower arm. A slight tapered section was next, and with a solid tool post installed, my best bet was another custom cutter. Setting my zero flush with the shoulder, simply plunging in to the minor diameter easily formed the feature, which I could verify with a test fit.
0.25? I think that's just about perfect.
The core of this partial cone would be occupied by other clamping related complications. So the last step before parting was to drill and ream an 8mm hole right through the center. The second side was a little simpler, with an 18mm section and precise shoulder, providing a place for this gear to go. And facilitating work holding for the finishing touches. A few holes around its circumference and a few more on its bottom face. Which I'd now attempt to thread.
When you're alone and life is making you lonely, you can always go downtown. When you've got worries, all the noise and the hurry seems to help, I know. Downtown, just listen to the music of the traffic in the city. Linger on the sidewalk where the neon signs are pretty. How can you lose? The lights are much brighter
God
there. You can't
damn it.
forget all your troubles.
It's my last
Forget all
M2
your
tap
cares,
as well.
so go downtown.
Unfortunately, despite an exhaustive list of attempted remedies, including carbide drills, photoablative micromachining, and a whole lot of swearing,
Fuck, I don't want to make it again.
the remnants of my failing remained firmly lodged inside the hole, and I was left with no choice but to start over.
So go downtown, where all the lights are bright. Downtown, waiting for you tonight. Downtown, you're gonna be alright now.
Alright, we're almost back where we started. Time for those tiny little tapped holes. Don't break the tap. I think that's gonna have to do for now. So the time has come to match the top and bottom arms on both of these faces. They're already really close, but they have this saw texture. So at the risk of completely ruining both of these parts, I'm going to try and quickly smooth that out a bit on the radius master. And then we'll do a bit of scraping and lapping and see if we can't get them nice and perfect.
Now, scraping isn't a quick process, but it's not exactly a fast one either. Still, my progress was steady, and chip by handmade chip, the working faces of the gauge slowly started to come around.
Okay, so I've got one side pretty good now, so I'm gonna start on the other side and try and get it parallel.
And after several hours of printing, scraping, lapping, and inspection, I finally got the error down to a reasonable margin. Pretty early on in the design, I realised that my lofty goals of form and function wouldn't be possible without at least a handful of custom fasteners. I mean, at least where I'm from, it's pretty rare to find a slotted screw with a 4mm head, a 2.5 by 2mm shoulder, and 1.8mm of M2 thread just sitting on the shelf. So with a little more silver steel and a threading die as cute as a button, I had the dial mechanism's 4 fasteners knocked out in short order. One by one, all of the high carbon components, bearing any real responsibility in the mechanism, were carefully heated and quenched. Any made of silver steel in water, and O2 in oil. In a less aesthetic application, this would be the time for a quick temper, to slightly soften the steel and bring back some toughness. But as I'd learned in my earlier attempt, temper colours look a lot better on a polished surface. And a polished surface is much easier to achieve when said surface is hard. So I got to work with all manner of methods, chasing that perfect reflection. Of course, there was never any hope of true perfection.
Now, annoyingly, this piece has some really tiny little marks on the flat. I don't know if you can see those, but they are pretty deep and I don't feel like sanding them out. So I think what I'm going to do is to match the arms, just flake that with the hand scraper. Kind of promising. I'd say that did the trick.
But once things felt close enough, heating each part to a fairly even and brilliant blue was simple, with the thermodynamic assistance of a bed of brass chips.
So my good friend Corin, who makes these delicious carbide tools, and also that incredible belt grinder over there, has hooked me up with this beautiful chunk of bronze, which we're going to use to make the knob. And the cover plate.
The former, in combination with the bronze spigot from before, and a collection of carefully ground pins, would hopefully handle my biggest gripe with off-the-shelf protractors, namely their propensity to lose position when locked. And the latter simply served to cover the adjustment screws on the rear of the tool, though it also happened to be the perfect place to put a maker's mark and semi-localized commemorative label. At this point, the only task that stood between me and assembly was marking the dial's 50 metric divisions and the needle's complementary vernier scale, and with the fibre laser already fired up, I was unlikely to find a better time. And yet, I hesitated for a moment as the thought crossed my mind that all I had to do to make this tool actually useful was mark those faces with degrees. So before we do anything we can't undo, let's talk about where the gradient even came from. As you may know, the metric system came about during the French Revolution. Well, I guess one of the French revolutions. The general idea was to create a universal and standardized system of weights and measures based on observable and fairly consistent laws of nature. And of course, the number 10. I mean, it was about time. According to this article from the BBC, at that point in history, there were more than 250,000 unique units of measurement in France alone. Besides the kilogram, the litre, and my personal favourite, the micrometre, This standardized system also proposed decimalized units for dates, times, and of course, angles. But unlike the Sumerian system, which seems to be based on the division of 1/6 of a circle, the folks behind the gradient seem to prefer their circles quartered. So what we know as 90 degrees, they called 100 gradients, giving a full circle 400 of the things. And from what I hear, that has some distinct advantages in specific fields, mainly those involving maps. But what interests me the most is their usefulness as the punchline to a very niche, long-winded, and almost completely unfunny joke. Anyway, Marius is German, so he'll get it. Let's put this thing together. Now, I love a good screw as much as the next guy, but when dealing with shafts at this small of a scale, alternate means of connection are often preferable. A light press fit, like the one I was lucky enough to achieve between the needle and its 20-tooth pinion,
Perfect.
is ideal for connections unlikely to encounter significant torque. But if you overshoot the strict tolerances required, a little bit of plastic deformation can really save the day. That is, as long as the shaft in question is able to bend before it breaks.
No!
The replacement pinion pressed into place much better. And then I could bring in its floating arm, retained with a bronze collar from behind. Then it was finally time to return to the much more hospitable realm of slip fits and fasten connections. Once I'd installed its trio of locking pins, the bronze pivot could drop into the upper arm. Then, the first spring fell into place, followed closely by the 15 and 40-toothed gears with their floating pivots. The second spring, and the last leg of the gear train came next, before a small spacer and the dial ring took their position on top. After that came the window and its frame, which takes 5 M1.6 fasteners from behind. A shim slips over the spigot for a sleek shadow gap between the upper and lower arm. These slots allow for adjustment of the 60-toothed gear to set the alignment of the dial at its origin. And once that origin is set nicely, I'll realise I forgot to place the pull stud, central to the locking mechanism.
Oh, I forgot to put the fucking pull stud in.
So it all has to come apart again. That taken care of, and the adjustment reset, I screwed on the hammer-toned locking knob and adorned the underside with its matching bronze badge, only to realise I had a serious problem. Some slop somewhere in the system meant the dial reading could lag behind the position of the arms by more than 1/3 of a gradient. It goes without saying, but that's completely unacceptable. So off came the badge, and off came the knob, then the lower arm, the window, and its frame. And after some deal of scrutiny, the gears came off as well. I realised that each of the dynamic connections had a small amount of play, which in isolation had gone unnoticed. But when combined, those clearances culminated in the extremely erroneous readings we saw before. So, with a smack here,
Just whacked that bronze retainer on a bit more. There is a lot less slop in that joint.
and a shim there, I steadily addressed the instances of under constraint until each felt snug as a bug in a rug.
Right, that's way better.
And eventually, I ended up here.
You gotta be happy with that.
Oh, Oz never did give nothing to the Tin Man that he didn't already have. And cause never was the reason for the evening or the Tropic of Sir Galahad. So please believe in me when I say I'm spinning round, 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 round. Smoke glass stained like a image going down, 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 down. So green like a no, I never did give nothing.
Cheese.
This is from James of Clow42. Probably been watching his videos for close to 10 years. I don't know what it is. Holly's read the thing that is on there.
Yeah, I was reading the description.
There was no spoiler alert.
No. Although maybe he just wrote that on there.
As a deception. It's big. I'm impressed with the size of the box. It's good packaging. All right, here we go. Oh,
Sick.
sweet. We've got some Clow 42 badges. Hell yeah. Should I put those on the van? Holy shit.
Oh my god, here, let me.
Okay. Looking pretty cool.
It kind of looks like a bomb.
We got some power leads. Go flying when it pops out. Holy dooly. That's crazy, dude.
That's so cool.
Oh my god. Now which way is up? Okay, that's the base. Right? I think. Yeah,
Makes
it's
sense.
got little rubber feet on it. I haven't spotted an instruction manual yet, so it might be just a plug it in and see what happens situation. Well, there is a little
TZ, time zone?
It's
24 hour?
amazing. Look at this thing. Crazy. Look at that.
Look at the gear, like,
Holy shit.
Yeah.
It's like what?
it looks like a bunch
1,
of fans.
2, 3, 4, 5, 6. Wait. I guess. Wait. Hang on. 1, 2, 3, 4, 5. Yeah, 6 stepper motors in there.
Yeah.
All right, James. I guess you win.
GPS antenna. So I can see where that connects.
Perfect. This is so clean. Plug it in. Whoa!
Waiting for GPS. Maybe we don't have good GPS in the shed. Maybe we need to take it outside to
I'll
start
try.
and then bring it back in.
Waiting for GPS. Come on, buddy. It's cool. It's like be interested to pull it apart and see what that PCB looks like. So clever. There we go. Oh my god.
It's moving!
That is the coolest thing in the
That
fucking
is
world.
crazy. So what does
This
it
is
say on the
incredible.
clock side? 7:43.
Presumably at the time. Sucked in, Marius. You just got a fucking metric angle gauge.
Been there, done that, messed around. I'm having fun. Don't put me down. I'll never let you sweep me off my feet. I won't let you in again. The messages I've tried to send, my information's just not going in. Burning bridges shore to shore. I break away from something more. I'm not turned on to love until it's cheap. Been there, done that, messed around. I'm having fun. Don't put me down. I'll never let you sweep me off my feet. This time, baby, I'll be bulletproof. This time, baby, I'll be bulletproof.
Oh shit. You're still here. Video's over, dude. Go and watch the Tool Room Takeover playlist.